Hello, folks. This is Mr. Tolbert's class, Physical Science. This is Mr. Tolbert's class, Physical Science. This here is going to be lesson number 3. Lesson number 3, where we start talking about the properties of gases. Here are the objectives. One of those objectives will be to define pressure, write and know the units for pressure, be able to tell examples of pressure, watch different examples of pressure like videos and other situations, understand the relationship between what a fluid is and pressure. And of course, there will be some type of quiz you'll have to take at the end of this lesson. So, once again, this is lesson number 3. 12.2 pressure. A force applied to a fluid creates pressure. Pressure acts in all directions, not just in one direction. Notice the picture here. The picture on the left, you can see it's kind of like a balloon. When you push down on the balloon, it kind of flattens out, but you can see the arrows are pushing in all sorts of directions, not straight down like if you were using a bowling ball. 12.2, forces in fluids. Forces in fluids are more complicated than those forces that take place in solids because, of course, fluids can change their shape. Here it is. You need to copy this entire slide, please. If it's in red, it goes in your head. The units for pressure are force divided by area. The units for pressure are force divided by area. One of these units you're used to. We typically call it PSI. We typically call that pounds per square inch. If you notice here, pound is a unit of force in the English, and square inch is a measurement of length. And the grid here is showing you for every 1 square inch, it's going to be how many pounds of pressure. But now we need to know the unit for force in SI. The SI unit for force is called the Pascal. Little rascal, Mr. Pascal. 1 Pascal is 1 Newton of force per square meter. 1 Newton of force per square meter. And meters are huge, so let's not get it confused. 12.2 pressure. If your car tires are inflated to 35 pounds per square inch, 35 psi, then a force of 35 pounds acts on every single square inch on the inside of your tire. Here's what it looks like, a microscopic view. On the microscopic level, pressure comes from collisions between atoms. Every surface can experience a force from the constant impact of trillions and trillions of atoms. This force is what we measure as pressure. This is an example that you'll have to know. It's also an example that you'll need to know for one of your guided readings. This is the example of engine pressure and how that explodes. In a car engine, high pressure is created by exploding gasoline-air mixture. Notice that the picture on the far left, that mixture of gas and air is compressed to a small amount of space. And then you ignite that, and it's going to take up more space as it expands.
The independent gas particles inside a slightly deflated basketball collide with one another and the walls of the basketball, causing pressure. How could you raise the pressure in the ball? You could add more air particles to the ball, As the number of particles increases, so does their number of collisions per second with the wall of the basketball, which first pushes out the walls of the ball and then raises the pressure. You can also alter gas pressure by changing the gas temperature. Warming up the basketball causes the gas particles to move faster. The faster moving particles collide more frequently with the wall of the basketball, causing a rise in pressure. As the gas pressure increases, so does the volume of the ball, until eventually the ball explodes.
This is the end of lesson 3. Now you're going to be taking a pressure quiz. No doubt it'll be on Schoology. Have a great day.